Hello, this is the next experiment which is related to the unit weight and yield of freshly mixed concrete. So today we are going to explain about this experiment which is taking the designation of C138 in ASTM, and it is related to the unit weight, yield and air content gravimetric of concrete. The purpose of this experiment is to determine the unit weight, so this is number 1, and yield is number 2, and the cement content number 3, and air content of freshly mixed Portland cement concrete number 4. So we have 4 different things. Yield is defined as the volume of concrete produced from a mixture of known quantities of the components. So this is the definition of the yield. Again, it is related to, as we said, the yield is related to the volume of the concrete produced from a mixture of known quantities of the component material. What is the significance and use? The unit weight value is used to calculate the volume of Portland cement concrete produced from a mixture of known quantity. So the unit weight value is used to calculate the volume. The main purpose is, or the main significance is, we're going to use it, is used to calculate the volume of the Portland cement concrete produced from a mixture of known quantity. Apparatus, we need several things like the measure and a balance. They are the major important things here. So a measure is going to be use a rigid metal water tight container with a known volume. A minimum volume of the measure is required for different nominal maximum sizes of coarse aggregate. For the 25 millimeter, which is 1 inch nominal maximum aggregate size, a minimum volume measure of 6 liters or 0.2 foot cubed is required. We need balance, tamping rod, internal vibrator, which is going to be an option, and a strike of plate and a mallet. The test procedure: first, place the freshly mixed concrete in the measure in 3 layers of approximately equal volume, as we have done before in the previous experiment. Number 2, rod each layer with 25 strokes of the tamping rod when almost 0.014 meter cubed or smaller measure is used. Otherwise, use 50 strokes per layer. So we have 2 options here, 25 or 50. Distribute the strokes uniformly over the cross section of the measure. Rod the bottom layer throughout its depth, but do not forcibly strike the bottom of the measure. This is important. Do not forcibly strike the bottom of the measure. For the top 2 layers, penetrate about 25 millimeter, which is 1 inch, into the underlying layer. Tap the sides of the measure smartly 10 to 15 times with the mallet, and this is the use of the mallet here, that you're going to tap on the sides of the container from 10 to 15 to release trapped air bubbles. And number 4, an internal vibrator can be used instead of the tamping rod. In this case, the concrete is placed and vibrated in the measure in 2 approximately equal layers. So if we're going to use the vibrator, this is the difference. In this case, the concrete is placed and vibrated in the measure in 2 approximately equal layers. We're not going to make the 3 different layers as in the case of the tamping rod. When the consolidation is complete, the measure must not contain a substantial excess or deficiency of concrete. A small quantity of concrete may be added to correct a deficiency. After consolidation, strike off the top surface of the concrete and finish it smoothly with a flat strike-off plate, using great care to leave the measure just level full, as we said. After strike-off, clean all excess concrete from the exterior of the measure and determine the net weight of the concrete in the measure, as we can see in this figure here. This is the figure, and as you can see, we strike off everything. Now we can weigh, and we can go with the next analysis step. So for the analysis and results, we're going to measure W, which is the net weight of concrete. This is the net weight of concrete over the volume of the measure. So this is what we call it W. And then Y, which is significance of the yield, it equals to, this is in meter cubed, it is going to be W1 over W. Okay, W, which is already that we have obtained in the first step here, which is the net weight of concrete, that is something we know, over the volume of the measure, that already we know also. Then the yield is going to be W1 over W, and then RY is going to be Y over YD. This RY, actually, it is we call it something, call it relative yield. So Y, it is the yield. This Y, it is, we call it the yield, which is supposedly to be the volume of concrete produced by or per batch. But here, this is the RY, this one, it is the RY, which we call it the relative yield. And it is going to be like the yield divided by YD. YD, we are going to call it like the volume of concrete that the batch was designed to produce. It is the designed yield. So we want to know what is the relative yield, you know, the ratio between our yield and the designed yield. Okay? And then we have something called N, which is the actual cement content. This is in kg per meter cube. This is what we call it, sorry. So this is